on source transformation. Let us consider the problem on the source transformation with the concepts what we have seen in the last class. So let me draw the circuit diagram. The circuit diagram consists like this. So it is having the multiple sources with the resistance and the voltage sources are there. So we'll have the current source in parallel with the resistance R1 we are having. So here we'll have the resistance in parallel, and here we have the current source here. So in any circuit given, so it is required to analyze how the circuit elements are connected. So how the series parallel combination are there. So these are the things we need to understand here. So this is the 6 ohm resistance, and this is the 6 volts, and this is 2 ohm, and this is the current source 2 amperes. This is 3 amps, and this is the voltage source with the plus 10 volts, 2 ohm, and the 3 ohm circuit element, and the voltage source with the. So here we need to find out, convert this into the simplest form, reduced into the single voltage source, reduced to single voltage source in series with resistance. That's a problem. In series with the resistance, that's a problem here. So we need to find out the reduce this network into the simplest one. So let us do reduce the network here. So here the various steps will be there. First we need to identify which are the circuit elements are present and how the series parallel combination will be there. So here if you look into this one, this is a 10 volts in series with the 2 ohm resistor, and the current source is there, and this is the one branch, and here it is connected parallelly across this one. So first let us convert this voltage into the current source so that these two current sources will come in parallel, and the resistance also will come in parallel, and we can reduce it to the simplest form. And also let us bifurcate the above branch with the below one, and similarly we can convert the 12 volts into the current source, and we can simplify that network. The simplified network, let us it has been shown here. So with the voltage source, I'm going to convert as a current source, and I'm going to bifurcate this one. So let us split this one. So this resistance will be there in parallel with the current source, and the current source 3 amperes will be there like that only, and the resistance 2 ohm, and I'm going to bifurcate this one. So here we have the 3 ohm resistor in parallel with the current source, in parallel with the other current source, which is called as 2 amperes. So with this one, we have the 6 ohm resistance in parallel with the other voltage source, which is equal to so minus plus 6 volts and also the 6 ohm. So here the 2 ohm resistor will remain same, and this is the current source. Since it's a positive and negative, so the value for the current is equal to I is equal to V by R. So V is 10 by 2 will become equal to the 5 amperes, and this is the 3 amperes will remain same, and the 2 ohm resistor will be connected here, and this is the 3 ohm resistor, and the polarity, the positive is there, it will become the head, and the negative will become the tail. So the value for the current I is equal to V by R. So it will be the 12 by 3 will be the 4 amps we'll get, and this is the 2 amps which is connected with the opposite polarity. And here we can see the two current sources are connected in the same direction. So 5 plus 3 will become 8 amperes. And also the resistance 2 ohm and 2 ohm are connected in parallel. So this will become equal to the single resistance. If you have taken the single R equivalent, it will be equal to the 2 into divided by 2 plus 2, it will become 1 ohms we'll get here. And here with the opposite polarity, we can make it as a 2 amps current source will get in parallel with the resistance. So the circuit can be reduced into the simplest form. So let me draw the circuit diagram here. So the circuit diagram consists of the single resistance in parallel with the single current source. Again, so the value for the current source will be the 8 amperes in parallel with the 1 ohm resistor. Again, we have the current source in parallel with the resistance we have. So the value for the current will be, so 4 minus 2 will be the 2 amps will get. The 4 minus 2 will be the 2 amps will get. And the value for the resistance is 3 ohm. 3 ohm. So this is in series with the 6 ohm in series with the 6 amperes, 6 ohm voltage source, 6 ohm resistance in the series with the voltage source. So this is 6 ohm and this is the 6 volts. Now what we can do is, so we can convert the current source in parallel with the resistance into the voltage source. Here also we can do convert here so that the two voltage source will come in series and we can reduce the network here. So this is the how we have done the network reduction. So this will become the voltage source in series with the resistance. Again, the resistance in series with the voltage source will get. Again, we have the resistance 6 ohm and the voltage source we have, so that everything will come in series parallel series combination with the same the opposite polarity. So this is the 6 volts power supply. This is the 6 ohm resistor, and the polarity of this one is depends on the polarity of this one. So the value for the voltage will be the V into V is equal to I into R. So 1 into 8 will become the 8 volts. And this is the 1 ohm resistor. This is the 3 ohm resistor. So this will become equal to the 3 to the 6 volts will get. So you can see plus minus are connected in series. Again, plus minus will connected, all the voltage sources are connected in series here. So 6 plus 6, 12 plus 8 will be the 20 volts will get. So the voltage will be 20 volts. So 20 volts in series with the resistance. The value for the resistance will be, so this is a series combination will get 1 plus 3, 4 plus 6 will be the 10 ohm resistance will get here. So this is the voltage. This is the final circuit diagram we get where the 20 volts is in series with the 10 ohm resistor we got here. So like this we can reduce the complicated network, which is the network which is being given like this, into the simplest form like this.